Welcome to our unit on rivers and coasts. My name is Gabrielle and this is lesson 2 in our unit, and this is all about flooding. So let's begin our lesson with a recap from lesson 1. This is a starter activity. What I'd like you to do is to copy this diagram into your books and see if you can label the correct parts of the water cycle. So this is a little bit different to the diagram that we looked at last lesson, but let's see how you go. If you get stuck, you can always check back on your notes from lesson 1 to see which part is which on the water cycle diagram. But all the key terms there are in the box, and you just have to label the diagram with the correct terms. So take a moment to pause the video at this point to complete this activity in your geography book. When you're ready to check the answers, restart the video. Welcome back. Here are the answers to our starter activity. Okay, so here are the answers to our starter activity. You can see that I've labeled all the different parts of the diagram with the correct term. So we've got the ocean, where large amounts of water evaporate through the heat from the sun, and as the warm air rises, it cools and condenses into clouds, and this leads to precipitation as the clouds get higher and higher. Now, if it's really cold, it might come down as snow or sleet, but if it's warm, it'll come down as rain. And so you have a lot of this water that just runs straight off the water, off the mountainside down into the ocean again. Some of the water will infiltrate, it'll go down into the soil and go down deep under the rock, or it might even percolate down into the rock or even up to the surface again where the trees can use it. Transpiration, which is when the trees release water molecules through their process of breathing, that can then go up into the atmosphere and condense to form clouds. That's why you get a lot of sort of clouds and mist and water vapor in the air and rainforests and places like that, because there's a lot of transpiration going on because there's a lot of plants. And any water that just flows through from, rivers into the ocean again is called through flow. Okay, moving on. Let's look at our learning objectives for today. Number 1, to describe the causes of flooding. 2, to analyze a flood hydrograph. And 3, to explain the impacts of flooding. So first of all, let's look at how flooding occurs, or how flooding is caused. Okay, so think about how the water moves in the water cycle, what processes are increasing or decreasing, and is the amount of water increasing or decreasing. So using the water cycle, explain what happens in a drainage basin if deforestation occurs. So it's just something for you to think about before we move on to the main part of our lesson. Okay, so how is flooding caused? Well, we can separate the causes of flooding into two lists, physical and human. So I'd like you to pick 3 pictures and explain how they cause flooding and link to the processes within a drainage basin. So for example, if there is heavy rain or it rains for a long period of time, how does this cause flooding? If there is a mountainous region with steep topography, how does this cause flooding? What if the ground is covered by impermeable rock? What happens then? What if there's a lot of towns and houses which are built? How does this contribute to flooding? What about if it snows? Is there flooding, or does the flooding come later? And of course, deforestation, which we talked about earlier. So all of these are related to causes of flooding, but for particular reasons. So this is just to get you thinking about the causes of flooding before we get into the explanations of that. Okay, so let's watch this video about the causes of flooding and hydrographs. And as you watch the video, see if you can just jot down in your notebooks 2 or 3 causes of flooding that are explained in the video.
In this video, I'm going to highlight the main causes of flooding and go through how you can interpret a hydrograph. So in this video, I'm going to look at the different causes of flooding and then also how to interpret a hydrograph. So you can divide the main causes of flooding into different categories, and we've got physical and human factors. So the first physical factor is how much precipitation. So when river channels cannot contain the large volume of water falling in a short amount of time, or if there has been sustained rainfall over several days, that can affect the amount of flooding we see. The different types of rocks, so we've got impermeable and permeable rocks. Permeable rocks allow water to be absorbed and therefore slowing down the water flow. However, impermeable do not allow water to pass through it, and this could lead to faster water flow, which could increase the risk of flooding. Then we've got the relief, so steeper slopes generally increase the risk of flooding due to faster runoff. So moving on to human factors and how we influence the environment. The increase of urbanisation and construction can lead to more flooding. So through the process of constructing new roads, housing estates and buildings, this can all lead to an increase in impermeable surfaces. So the amount of deforestation we see. So as the forests are cleared, this takes away a lot of greenery that naturally absorbs and uses water. Clearing woodland can dramatically increase the risk of flooding. And then we've got farming. So if the soil is left bare and there are no plants to intercept the rainfall, again, this can lead to further runoff. A hydrograph shows the amount of discharge into a river following precipitation. In this example, the yellow bar chart shows the amount of rainfall over the specified hours. In this case, the peak rainfall was around about 12 o'clock. Following this peak, the amount of discharge shown by the blue line increases, and this is referred to as the rising limb. The peak discharge of 55 cubics occurs around 9 o'clock in the evening. Lag time is one of the most important pieces of information on this hydrograph. The lag time is the time it takes between peak rainfall and peak discharge. This is how quickly water is transferred into the river. Once the discharge has peaked, there will be a gradual reduction and the falling limb will track the discharge back to its normal flow. Thanks for watching. Make sure you check out more videos in my rivers series and subscribe.
Okay, so just one video question. Describe 2 or 3 causes of flooding. And when you do, just make sure you label them as either physical or human factors. Right, so in the video they talked about a flood hydrograph. So let's just quickly recap what that is. So a flood hydrograph is used to show how water flows in a drainage basin during times of heavy rain. It can be used to predict and analyze flood events. Hydrographs show rainfall and river discharge. So this is a partially completed flood hydrograph. The red line shows how much water is flowing through a drainage basin, measured in cubics, and the rainfall is shown as the blue bars on the graph. Now, let's take a look at a completed flood hydrograph so that you can answer some questions about it. So let's study the hydrograph below and answer the questions. There's 4 of them there. So I'll go through the questions first. 1, at what time on day 2 was peak discharge? 2, how long did it take for levels to return to normal after the peak? What was the lag time between rainfall, peak rainfall and peak flooding? And 4, how many cumecs were discharged at peak rainfall? So let's take a look at the first question. At what time on day 2 was peak discharge? So we're going to go up to the top of our graph here and we find peak discharge right up the top there. And this was probably at about 1 o'clock in the morning. So 12 o'clock means midday and 0 means midnight. So about 1 o'clock in the morning on day 2 was peak discharge. So about 12 hours, 12, 13 hours between lunchtime or 1 o'clock in the afternoon when the rainfall started falling and about 1 o'clock the next morning. So how long did it take, question 2, how long did it take for levels to return to normal after the peak? So if 1 o'clock in the morning was peak discharge and the levels go back to about normal, sort of roughly at the 0 point or 5 point. So we can see that it's probably about 1 day, 24 hours, just under 24 hours for that level to return to normal. 3, what was the lag time between peak rainfall and peak flooding? So here is the lag time here. So peak rainfall was at about 2:30 in the afternoon, 2 o'clock in the afternoon, and peak discharge was 1 in the morning. So from 2 in the afternoon to midnight is 10 hours, so about 11 hours, basically between peak rainfall and peak discharge. And 4, how many cumecs were discharged at peak rainfall? Well, peak rainfall's over here, and the amount of cumecs is roughly 19, about 19 cumecs, just under 20 of runoff or discharge, that means water, was was discharged at that time. Okay, well that brings us to the end of our lesson on flooding. Thanks very much for watching. Don't forget to visit our website www.voyagerschool.com.au for more valuable courses in more subjects for high school students. See you next time.